Function notation. Equations can be written in a form called function notation. We use this as a quick way to evaluate functions for a given input. Example, y equals 2x minus 8. We will write this as the following. We read this as f of x equals in this example, f of x equals 2x minus 8. When you evaluate a function, you take the given value for the x and you place it into the expression. To evaluate a function for a specific value, substitute the value in for x. Example number 1, f of x equals x plus 7. You will take the number inside the parentheses and plug it in for the x. Watch the first 3 examples for number 1. For example A, I took 5 and replaced the x with 5. 5 plus 7 gave me 12. Therefore, f of 5 equals 12. For example B, I put negative 1 in for x, giving me f of negative 1 equals 6. For letter C, I replaced x with negative 3 and did negative 3 plus 7 to give me 4. Therefore, f of negative 3 equals 4. For the next example, my function rule is g of x equals 3x minus 8. I will replace the value inside of the parentheses where the x goes. For letter A, I will do 3 times 1 minus 8. That gives me a solution of negative 5. So g of 1 equals negative 5. For letter B, I will replace the x with negative 3. For g of negative 3, I put in negative 3 in for the x. 3 times negative 3 is negative 9, and negative 9 minus 8 gives you negative 17. Therefore, g of negative 3 equals negative 17. For the third example, letter C, I'm going to replace x with the number 0. When I replaced the x with 0, I did 3 times 0, which is 0, minus 8, which equals negative 8. Therefore, g of 0 equals negative 8. Example number 3 says h of x equals 2/3 x minus 1. You will have to replace the number inside the parentheses with the x in the function. For letter A, I'm going to replace the x with the negative 3. We will multiply 2/3 times negative 3 and then subtract 1. When I multiplied 2/3 times negative 3, I got negative 6/3, which is negative 2. I then took negative 2 and subtracted 1 to get negative 3. Therefore, h of negative 3 equals negative 3. For the next example, I will put 0 in for the x. Any number times 0 is 0. And 0 minus 1 is negative 1. Therefore, h of 0 equals negative 1. The third example with this function rule is h of 9. I will put 9 in for the x. To multiply 2/3 times 9, I will do 2 times 9, which is 18, divided by 3, which is 6. I will now do 6 minus 1 to get my solution. I came up with 5, so h of 9 equals 5. For example number 4, my function rule is f of x equals x squared minus x. Be careful when you're squaring a negative, as any number squared will always be positive. For letter A, I will do negative 4 squared, which is positive 16, minus negative 4, which is really 16 plus 4. Which equals 20. Therefore, f of negative 4 equals 20. For the next example, I will replace the x with negative 1. First, I will do negative 1 squared, then I will subtract negative 1 from it. Remember, when you're subtracting a negative, that's really like adding a positive. So I come up with f of negative 1 equals 2. My third example, f of 7, will require me to replace the x in both of the expression pieces with a 7. First, you evaluate your exponent. 7 squared is 49. And 49 minus 7 is 42. Therefore, f of 7 equals 42. For the next example, make sure you square your value for x before you multiply by 3. I will first square negative 4, which is negative 4 times negative 4, which gives me positive 16. You need to multiply 3 times 16 to give you 48. And then add 7. When you add 7, you will get 55. Therefore, h of negative 4 equals 55. Go ahead and try letter B and C. When you evaluate h of negative 2, you should come up with 19. Notice I squared negative 2 first, then multiplied by 3, then added 7. When evaluating h of 0, make sure you start with 0 squared. 0 squared is 0. And 3 times 0 is 0. And 0 plus 7 equals 7. Therefore, h of 0 equals 7. For number 6, again, make sure you input the value for x. Be cautious as there is a negative in front of your x, so you have to square your x value and then multiply by negative 1. If it helps, write negative 1 and then your x value in parentheses. Remember, when you're distributing a minus, you're really distributing a negative 1. So go ahead and put that negative 1 in front of your parentheses. Take care of your exponents first. Then, take care of your multiplication. Then, just like in order of operations, you take care of any addition or subtraction from left to right. You should come up with negative 31 for the value of f of negative 3. Go ahead and try letter B and C. When you input negative 1, you first square negative 1, which gives you positive 1. Then you multiply it by negative 1. That gives you negative 1. Then you multiply 6 times negative 1. That gives you negative 6. So you have negative 1 minus 6 minus 4. Negative 1 minus 6 is negative 7, and negative 7 minus 4 is negative 11. Therefore, f of negative 1 equals negative 11. Again, start by multiplying 5 by itself, therefore squaring it. 5 squared is 25. However, don't forget you have a negative 1 being multiplied on the front. Multiply negative 1 times 25 to give you negative 25. Multiply 6 times 5 to give you positive 30. And bring down your minus 4. Negative 25 plus 30 is 5, and 5 minus 4 is 1. For 7, 8, 9, and 10, continue by plugging in the value of the x into the expression. For number 7, you are going to multiply negative 1/2 times your x value and then add 9. For number 8, you will multiply negative 4 times your x value and subtract that number from 2. For number 9, you will square your value, multiply it by 2, take your value again, multiply it by 4, take those answers, put them together, and then subtract 9. Number 10 is a little bit trickier as it's talking about absolute value. Let's go through example number 10 together. Example number 10 says g of x equals the absolute value of x minus x squared. Remember, absolute value just means that the answer must be positive. Watch as I plug in the value for letter A into the expression. Letter A says g of 4. I will put 4 into the expression. I first wrote down the absolute value of 4 minus 4 squared. I evaluated 4 squared to get 16, so then I had 4 minus 16. 4 minus 16 is negative 12. The absolute value of negative 12 is positive 12. Therefore, g of 4 equals 12. Sometimes you will be given a function in a word problem, like number 11, which states, anthropologists use the length of certain bones of human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61.41 plus 2.32x can be used. You would use this function to plug in the value given to you to solve. Letter A, find h of 46. Remember, 46 will be plugged in for the x. To solve this, you need to multiply 2.32 times 46 and then add 61.41. The second question asks you, what does this mean? Well, it states in the third sentence, to estimate the height in centimeters of a female, the function will be used. The answer for letter A will be the height in centimeters of the female with a femur length of 46. So, let's evaluate. If we do 2.32 times 46, you get 106.72. We add that to 61.41. I came up with an answer of 168.13. Let's answer letter B. What does this mean? This means that a female with a femur length of 46, because remember, X represents femur length, as written right there, a female with a femur length of 46 has a height of 168.13 centimeters. Number 12. Given the graph of the function f of x, find each of the following. What you will need to do is take the value given to you and plug it in for x. Letter A, f of -4. You need to go to -4 on your x-axis. That is your origin point. Go 4 places to the left and find where the graph hits -4, which would be right here. The y value will be the value of your function. So if you count up from the x-axis, it would be +2. Let's try letter B, f of 0. f of 0 is located right here. That is 0 on the x-axis. f of 0 for this function is 0. Now let's try f of 2. Find 2 on your x-axis and find where the graph hits it. This point has a y value of -2. And the last example is f of 5. Find +5 on your graph. This will be located on your x-axis. Now, find where 5 hits the curve. The y value will be your solution. So in this case, the y value is -1. Remember, the number inside the parentheses is the x, and the solution is the y. This is how you create an ordered pair. Notice the red dot on the graph has the ordered pair of -4, +2.